Now he has a doctorate. You know how long he has been working on artificial intelligence. He has graduated from a school in France, and he has PhD in active database from University of Toulouse. He has an MBA from Warwick Business School, and he has published in international journal conference. So he's an academic and professional at the same time. So he combined what I'm calling it rigor and relevance to address societal challenges. You are welcome, Dr. Tawbi. Well, not to mention that Dr. Al-Sayed, he is from the north, from where my heart is lying. We are both from the north. Dr. Al-Sayed, he is the chief IBM scientist, data scientist at IBM. He is a part of cognitive systems. Some of you know what's cognition, so we'll hear a lot, because cognition analytic management, it starts from cognition. And for that reason, we are starting today with cognition with Dr. Al-Sayed. Now, Dr. Al-Sayed, he has an extensive research and experiences in artificial intelligence, machine learning in different sectors. We invited him to speak about experiences relevant to Lebanon, in particular the telecom sector, the finance sector, the retail, and the banking. And he will shed over the next 2 days, today and tomorrow, both of them experience relevant to Lebanon. Now, Dr. Sayed, he's covering similarly the whole region, even beyond Europe, Middle East, Asia, and Africa. He has a PhD in computer science with specialization in machine learning, information retrieval, and he has published a lot of paper as well. So for your experience, if IBM, you don't like working there, I can offer you a job at IUB as well. So we are doing a training for you test to see how good you are. So you will evaluate it later on. Thank you very much.
Thank you, Dr. Brahim. Thank you, Dr. Brahim. I didn't know that it was an interview session, so please, thanks again. Thanks for inviting us. Thanks for inviting IBM for this session. We are really pleased to collaborate with you today and in the future on AI and cognitive and in analytics. As Dr. Brahim said, you know, I've been working for IBM for 18 years now, and mainly on data and analytics. And today, you know, I'm leading also the data science part. And, you know, I will try, it's 1 hour 30, I'll try to make it a bit interactive maybe, to not feel it's very long. So if you feel, you know, at any point of time you have any questions, really, please feel free to stop me. So I'll start with a video about how IBM, you know, you know, how we see AI.
I am a technological breakthrough. This morning, I read over 4,000 articles on Wikipedia in less than a second.
So as you see, and as you know, AI will change our life. It is a fact. It is like it started changing our life. From many perspectives. From we are experiencing this every day in all our mobile phones, everywhere, and we see that all companies, all industries are investing in this area. So my agenda, will be as follows. I will speak about the history of AI. Just as a reminder, when we started doing AI, how I think there's different definitions today of AI. So I will go through, I would say, the public definition and how IBM is defining AI. So the idea, again, I want to let you know how IBM is addressing this topic. And of course, how we can help you really to address it together. We think, and I think it's a reality, we cannot build AI without data. Without quality of data, without the right data. We will go through this as well on how we can organize our data, what platform. IBM also, we can help you, we can help companies build a platform, because to build AI applications and cognitive applications, you need a platform. Okay? One of the problems we will go through, I wanted really to address, is the trust in AI. And I think this is one of the inhibitor today to adopt AI. So we'll go through this as well. Some references, but my colleague, Dr. Ahmed, will go more in use cases, more details. But I will give you some of the applications of AI today. And later on, we'll speak about the skills, the lack of skills. And this is, again, another inhibitor in the market to adopt and really to start doing AI. Okay? From history perspective, AI is not new, right? We start speaking about AI 60 years back, even before. Some people speak about automation even before. But the first really attempt to speak about AI was in 1950, where Turing, all of us, maybe the Turing machine, and Turing for his work on building the computer as we know today. And maybe you have seen Imitation Game, the movie that speaks about, we all in computer science. I don't know, the new students that are studying. We started, the Turing machine was a very important things for us, but we were not able to know, at that time when I learned it, I didn't know the origin of Turing machine, right? And in this, because it was a confidential information, and they did the movie 5-6 years back. Once the UK government, they gave the information about what happened at that time. The Turing machine has been built to decode or to find the code of the German, And you saw at that time as well, speed. I don't know if all of you have seen this movie, but invite whom you didn't see it. It is very interesting. And also in computer science, it touched me because I knew what does it mean. Turing machine. So at that time, speed was important. It was also, even if it wasn't AI, but it was also, computing power, it was important. And without that, they couldn't really decode or find the code, because they have to do it in the 12 hours during night or something, because the encryption was changing every day. Okay? So at that time, and 5 years later, because they did Turing machine around the 43, 44, Turing started thinking about if we can make machines intelligent, okay? And he is the first one to do a test. This test was put together he was saying if we ask a question to two different entities we don't know, are hidden for us, and if we don't know if it's a human who answered or a machine, then we can reach a point where the machine is smart or intelligent enough. So this was the first work on, I would say, AI as we know today. Then the first time we mentioned the term AI was in 56. And over time, we started, maybe the first temptation or the first work on AI was on expert systems, Okay, building knowledge bases and doing like using intelligence to try to replace, or not to replace, but to replicate the knowledge of experts. And during some years, we went through what we call the AI winters. And by the way, we'll get to this. We are today discussing what we should do to avoid this, to avoid getting, again, maybe setting the expectations of AI very high to a point where maybe we will be frustrated. And trust, I will get to this later on, is one of the problems that says there is a risk to go again in AI winter. So we have really to address all things today to really embrace AI the right way. And so on and so forth. You know, the first time, and this is where IBM starts really helping the market, and that the first time we have done really, we demonstrated that machines can be smarter than human beings was in 1997, where IBM, you know, I don't know if you have heard about Deep Blue. It was the machine that has been built to play chess with Kasparov. And I got the chance to have Kasparov in a IBM conference. He was a guest speaker, and he said, it was like 6-7 years back, and he said, I'm still frustrated. So how I could be bitten by a machine, okay? So it was the first time where we can prove that we can build a machine that it is quicker and smarter than the worldwide champion of chess. We have done a lot of this kind of I would say, research. The Go game. Gaming is not for gaming. You know, IBM did it just to prove that we can do, like, this is things that we want to bring later on to the industry, okay? And we, after this Deep Blue, after the chess, we moved to the next level where we built Watson. And again, you know, it's now 8 years back or 7 years back, but still it's one of the application which is pioneer and which brought really AI to another, I would say, the next level. So again, sorry if it's you know about it, but I invite you maybe to go to YouTube and see some videos. Again, Watson was the attempt to build a like kind of general information brain, let's say, and being able, again, this is based on a game called Jeopardy. I don't know if we have got it in Lebanon or not. We give a series of information about a fact, an event, a date, or and there's 3 players, and the 3 players should guess what's about. It's a city, and again, we selected the 2 best players in the US, and we put Watson in front of them. What we had to do, actually, we had to build a knowledge base of, like Wikipedia, let's say, that, you know, based on here where we bring to the picture the natural language processing. And you will see the natural language processing is very, very important in AI. So we were able, you know, to tell the question to the human being and to the machine at the same time, voice-based, and the machine was able to interpret the voice, to find the answer, and to be quicker. Again, look to the quick thing. It is very important, this speed of things. And then, of course, Watson, as you have seen in the video, now what we are doing is we are bringing Watson to the market. You know, means that, okay, we have done it as a game, but the technology behind can help us in our life. And we brought it to the healthcare, to weather prediction, to industries, to oil and gas. We'll see some examples. Any questions so far? I said I want to make it a bit interactive. But did I miss any milestone you think that it is important in AI? So, yeah, during the, you know, on algorithms and evolution, again, if you take it through years, we start doing, as I said, early 50s and 60s, and the first applications of AI was more expert systems. Where we started really leveraging AI more was with machine learning. So machine learning in the 80s, and one of the first applications of machine learning is the spam detection in emails, and how we can make the email servers able to detect spam. Also, some of the early adoption or early applications of machine learning is OCR, optical character recognition, that we use today in scanning, and it's based on machine learning. What also now I would say a game changer is the deep learning. Deep learning is the technology, again, that is helping us to do complex things that we cannot do before with neural network. So deep learning, one of the application is image recognition. Okay? Image recognition is one of the application. Of course, there is other applications, but this is, and again, here where we see machine learning or deep learning, their problems is again, having the computing power, because if we have very complex problems, it might take time to really to get the right training of our machine. Okay? So one of the things that really is, as I said, really changing our and really triggering all of this is the explosion of data. Okay? I put this picture you see today, and 20 years back, maybe when we were going to a concert, maybe we should take one picture, or we have our big cameras, and today in any concert, you see these lights, they are the phone, the mobiles, people are watching now concert like this, so they are streaming, most of them maybe even streaming. And you see one concert or one event like this, how much data it can generate. It is huge. And I put some example of what's happening in a minute today in our life from data generation perspective, okay? If you look to that, there is many examples that touching us, YouTube, 4.3 million video streamed in 1 minute. Let's say Netflix, 266,000 hours per minute are streamed on YouTube. And you go on and on, tweets, 481,000 tweets. Uber and other, 187 million emails. And it's going exponential. It's going exponential. And this is one of the things where it's triggering all of this, saying, okay, if we have all this data, all this message, what we can do. And some of these companies, by the way, are the pioneer in leveraging data. If you take Google, if you take Netflix, if you take Airbnb, these people, what we call them born digital, these people are leveraging the maximum of their data. And you will see in one of the problem of the industry of organization, they are not that, while we estimate that these born digital companies, they might use 80 to 90% of their data or our data to shape even their business models. The organization today not touching more than 10 to 20% of their data as per today. We are still very far. And this is important to be able, if we have all this mass of data, to leverage it, this is where cognitive AI analytics can come to the picture. Okay? So not only data, but also this is, I think we are lucky. Yeah? What's happening, there is other factors as well happening at the same time. Remember, data is there, of course, but we can say, okay, we have got data 10 years back, maybe not exponentially growing, but some customers might tell you, yeah, 10 years back, I've got a lot of data, okay? The problem is the cost, it was to the computing power and the algorithms at that time. Today, all of this is coming together. Computing power is accessible, even is cheaper than before, and with GPUs and even quantum maybe coming 5-10 years ahead, this is a game changer. And remember, speed and being able to process a lot of data is very important. So computing power is not becoming like really, the power of computer becomes big, but also become popular. Because today, when we speak about cloud, the companies offering APIs or really capabilities for even startups. They can access to really huge power, even a startup. So today what I tell my customers, I teach in some universities about what's important today is ideas. If you have an idea like the next Uber, the next Airbnb, this is what matters. Implementing this, we have access today, popular, even democratic access to data, to the computing power, and the third thing is the algorithms. There is a lot of studies today, and when I say algorithms, one of the things who is helping to progress and to improve algorithms are open source communities. Most of these algorithms are today like growing and really being improved by the open source community. So yeah, this is again, I think, an opportunity and a chance to have all these factors combined together at our time. Okay? It's very slow. So from definition perspective, again, I have academic people in the room, and I don't want to go, but just as I said, the definition, the main definition is, how we can make a computer or a machine smarter or really thinking like a human being. And you see in the market, or this is why I said it's a buzzword. AI, it's mixed with many things, and I think Dr. Ahmed will go more on this. So it's mixed with machine learning, but there is a subset of AI. The speech recognition, the machine learning, the robotics today. All of these are, I would say, subsets of artificial intelligence. Again, I will let Dr. Ahmed go more in details on this. This is what I would say the definition in general. This is how IBM. Yeah, so IBM, again, what we are saying, we want, and this is the basic definition of AI, how to make the machine smart or smarter or intelligent, okay? So the first, what we have done is we have done a study on the cognitive side, on how human beings, how children, how they learn in their life, what's the process. And based on sociologic and really surveys and discussion with specialists, we identified 4 phases in our cognitive process. In any interaction we have, we go through these 4 phases. The first one of them is understanding. Today, if in any interaction, if I don't understand the language, if somebody asks me a question in Chinese, even if I know the answer, and even if I'm a bit smart, I will not be able to answer because I don't know the language. So understanding is very important. And this is where I would say we made a lot of progress on this part of natural language processing. And understanding, by the way, is not only language, is also vision. The vision, the context around us. It's around understanding what's around. Today, the self-driven cars, they need this vision recognition. Maybe they need this speech recognition. If you are a driver or you are sitting in the car, you can give maybe like a verbal comment. But at the end, this is what human being does. I need to understand what you are like, what you are asking me. The second, what I do is I do a reasoning. Reasoning is actually I evaluate the answers. I might have different answers, and in my mind, I will put probabilities on which answer is the best for what. And it's based on my experience, my knowledge, my inference, how I link what I understood to other knowledge I have. This is actually what I do. Then, based on my decision, even if it's wrong or correct, I will learn. Okay? This is how and finally, this is happening, of course, in seconds, right? Again, speed is very, very important. So then I interact. So I answer the question, or if I have been asked to do an action, I will do the action. And this is exactly. So IBM, when we spoke about Watson, and this is what we tried to implement. We used machine learning in each one of them. So you see that machine learning can come under these different steps, but these steps are very important. Then what we have done as well, so we split these, I would say, different phases in capabilities. So what does that mean, understanding? I will not spend a lot of time on that, but at least let's take maybe the language side. Natural language processing is not just about understanding the phrases, the verbs, and it is also understanding the context. It's, for example, Arabic is a very complex language, and you know that the words, depending on how we pronounce it, the tone, or it might have different meaning. But also, and what's where we made a lot of progress in this on speech to text, for example. Today, this is what allows us to ask Alexa a question or Siri or Google Home. It is the speech to text. Behind this, it might be very simple. It's a Google search, right? But the speech to text is very important. Then Alexa has the text to speech. IBM, we have this capability as well, but we respect what other people are doing, okay? So speech to text and text to speech are also language-based capabilities that are very important. We pushed it further. In language as well, in our discussion, in our interaction, the tone can make a difference. So we have capabilities to analyze the tone of the phrase, the tone of the voice. And this is, again, it can help in understanding the context, understanding if we have got an order, or what's the interaction we are having, what level of tone we have. We have done as well, like sentiment analytics. This is another very important topic, where today, and you saw the social media, and social media today is a lot of companies are using them to analyze, to react to maybe negative or even positive comments about any service. For example, a bank today, a telco company, they are monitoring Twitter all the time, for example, and if somebody is criticizing something, they call them in the next 5 to 10 minutes. They are this is again, it's based on language, but it is the next level of. One of the capabilities as well we implemented, and it's used by some of our customers, is personality insight. So Dr. Ibrahim, if you want to analyze my personality for your interview, so what we can do today, just posting the Twitter address of anybody, you can go and test it on internet, on public, there is a public link, it's called Personality Insight. You can go and see, you can actually put the Twitter address or Facebook address, it's an open public, maybe company or whatever, and it analyzes the personality. I tell my people, don't do this in front of your customer. Don't ask them, give me your Twitter address during a demo, for example, and put it, because the results sometimes might be like surprising, because it might be like a wrong, I told them, please test this before, if you want to impress your customer, and it's impressive, it gives you the trait of personality, and it can link. We have another website, I can find it. You can put your Twitter address, and it can match you with some celebrities. Okay, so it can. One of the fashion companies, what they have done is you put your Twitter address, or again, the idea here is to analyze your style of writing. If you are positive, you are negative, you are detailed, analytical, whatever. What they have done is they posted on the website, they posted their designer's personality. When you put your own Twitter, it analyzes your personality and it matches it with designers. So if, it is good for you women here. So it will tell you if you match the personality of this designer, you might like the bag or the dress he or she has created. And it's very, very, for me, it might, I know that some of the HR companies, they start using this kind of things. But again, I think we are making progress. We might need to do more, but please test these kind of things and you see where we are. So, and so on and so forth. As I said, visual recognition is another really important things. It's where we are today. As I said, yes, please. No, that's fine.
You gave the example of HR, and when you're presenting, technology-savvy people that present these topics as simple as it's supposed to look. But they don't look inside this black box, because in your illustration of IBM, learning is the first step. But what you learn from data. Well, what kind of data? Is the data biasing me to work in a certain direction? And when you're talking about HR using it, I call it personality assessment. It's not really personality testing. I have been tested so many times I ended up being an introvert. I have been teaching in university since '87, and those who know me know that I'm not an introvert. In addition to that, they place you and they bias you in that respect. And the learning by itself has been happening all along. What happens here, we have a huge amount of data that human mind cannot process it as efficiently and as effectively. In the banking sector, all what technology did improve the customer experience. It did not really reinvent the wheel. Internet banking is branch banking. You take your choice, ATM or ITM, just you pay. It did not really add to the banking experience, to the banking technology, to the banking concept. Just improve the customer experience. So it's not really as easy as you make it to be. I'm a user. I'm not a technology person. But you present the technology as if it's going to solve all of your problems. No, it's not. Descriptive analytics, well, we always described it that. Now we call it fancy descriptive analytics. And then we jump to diagnostic analytics. Well, we always say, what's wrong with my loan portfolio? Now we call it diagnostic analytic, and then predictive, and then prescriptive. Well, we've always done that. Today we have 152 variables to assess the risk in the loan portfolio. No human mind can do. And I have to go back, cross-sectional and time series, about 10 years or 5 years. Well, of course you need technology, but it didn't change banking, it didn't change medicine, just communicated, it facilitated the communication, speeded up the process, made it more effective, but in certain areas it could bias the outcome, because even today with artificial intelligence, garbage in, garbage out. Because with every adding, as you add any piece of data, it could improve or otherwise.
Very good. So I think you have read the next 2-3 slides or the next of the No, thank you so much for your intervention. First of all, I called my presentation AI Journey. And as I said, we are just starting. Second, we in the trust side, and you will see that IBM from bias perspective, we are trying to do, because it's a black box, as you said, and deep learning, all the people who knows deep learning today is a black box. So we are trying to open this box. You will see there is some work on this. On the different types of analytics, you are absolutely right, and you will see we're still considering them depending of use cases, what types of analytics you need to do. And your question about, yes, HR or other specialists might be biased. We want to, our AI, and IBM at one point of time is still calling it augmented intelligence, okay? We say it can help people to take decisions, but it shouldn't be the only way to take decisions. So this is, I hope this answers some of your, but yes, I agree with you, this is data in, sorry, please. Sure, please. No, because it's fine. No, fine. We will have the conversation offline. Yes, today I think we are just starting. As I said, quality of data and amount of data. There is some use cases. Again, for me, the way or the algorithms we should choose depends on the use cases. And Dr. Ahmed will go through this. And even when we speak use cases, this is why I said there is buzz in the market. Some of the use cases might need just descriptive analytics or it's not all AI. Today you will see a lot of companies, everything is like AI. We are doing AI-based whatever, but when you go in detail, it's just a machine learning that we have been doing 10, 15 years back. IBM, we have got capabilities on machine learning and prescriptive and descriptive, all these analytics for 15 or 20 years. It's not new. Now what's new is more data, but we need, of course, when I show this billion or 100 zillion, of data that are available, and people are telling, yeah, in the last 2 years, we generated as much data as all our life. What I like to say is, yes, but we did not generate as much knowledge as our life. So it means that we have to deal with the data carefully. We don't need all of this data. Maybe 90% of it doesn't mean anything. But of course, we have today the technology to be able to read in this data, to go in unstructured data, in voice, in things that wasn't available before. Now, how to leverage this is a journey. It needs a lot. We need to build a data platform. We need to cleanse the data. And I will go through this. But yeah, enforcement today, it's amazing what we can do in enforcement on some gaming, for example. In gaming, it works very well. And you give today just the rules to a program, and in less than 24 hours, it might learn the game and play better than any human being. There is a lot of different subset of AI that should be picked or used or depending of use cases. Use cases are key. Understanding, use cases is key to choose what technology to use. Again, I will not go very, and you see, this is what just I have been saying. It's you need to build on. You need first to build a platform. You need to have a platform that can acquire or ingest any type of data. You need after, these APIs I'm telling you about are sitting on top of the data. You see here, for example, the AI cognitive building blocks. And also what we are offering, this is the top level. In some areas, we have ready-made applications. For weather, for example, we have applications for healthcare, like we have for now legal. Everything where there's a lot of rules and a lot of information. For example, in healthcare, why we did a lot of progress in healthcare? Because there is, today we say a doctor can maybe read one article every week. My uncle is like, I have seen him, maybe taking, just to follow up on what's happening in his area. He is gastroenterologist. But one article a week. We estimate that every day there is 12,000 articles in medicine and in healthcare. And imagine that a doctor can access what's happening, what technology is coming, what new medicine is working better on this disease. Because he cannot follow up on everything. So here what we can do is ingesting this 12,000 or whatever, data that it's generated every day. We can be up to date all the time. So these kind of applications can accelerate and can be assist or as I say, augmented intelligence, assist the specialists. Today in the cancer side, we work with many research centers and we help them. We have today a system that can read the X-rays. There is a algorithm that do a vision recognition on X-rays. It's better than a radiologist. It helps him. It helps him to maybe see very small details that maybe it's not very detectable or sorry. My? Yeah, maybe I'm not there. Yeah. So this is the kind of things that can help, as I said, help the experts, giving them information. Some of the challenges we have today, and as I said, there is a big change of our society. We need to take care of this. Technology advancement is helping us, but also we need to put the right architecture, the right infrastructure in place. Skills, as you know, it's really a big challenge. Okay, we need to have, and one of the is the perception. Perception is one of the, and as I said at the beginning of my presentation, perception might bring us to another AI winter because people will say, "Oh, no, I don't want to use. I don't want to trust. I don't trust." And this is why we are doing now the next level. We are trying to open the box, try to always being able to explain what data has been used to take this decision. Now, this is, you will see later on. One important thing, and I think tomorrow we'll have government people, is about like putting governance. It's not, but I'm saying governance because I see in the region, the government are very involved in putting like ethics and creating rules on how to use data. Today GDPR, for example, in Europe is one of the people, even Europe is they're stopping them. When we see deep learning, GDPR and deep learning, they don't match. because we cannot tell why, for example, in GDPR, we have to explain to a client, sorry, why we refuse the loan. For example, if we use very scoring, very complex and deep learning, we might not be able to explain. So this is why I think these rules and eliminating bias. I will give this example about bias. And again, IBM we have done a review on one of our visual recognition, face recognition program, and we figured out that it doesn't recognize black females. 33% error when it is a picture of black females. And we have compared with other competitors about 23%, 15%, but it was very big. 33% is not. When we get to the data we use to train the system, we just figured out that we did not use enough black females images in training the system, because the guy who was training the system, maybe he didn't care or he didn't choose these pictures. And now we went down to less than 3%. But we should have, we need today something who can explain us why we are biased as well. So bias is very important, because human beings, when we are programming and programming or putting these data and training the systems. If we train them with the biased data, they will be biased. They have done also something about black, again, in the US, that the black are less, it's less, sorry? Yeah, exactly.
The bank used artificial intelligence and credit scoring at the detail level. They ended up voting out all blacks, all of them.
But
The data shows that blacks are more likely to default.
Very good. One of the examples as well I liked is when they do juries in the again, this example from the US, they have discovered by analyzing and this is predictive, it's not really, they have discovered that the voters, when they vote, these juries, if they do it in the morning, they are more towards saying innocent. Then when they start to be hungry, when it's really coming to the midday or so, they start really voting no or incriminating people. By just again, this is a human being, and with data, we were able to analyze and to find this kind of things. And this is why it is exciting and amazing what we can do with the advancement of technology. So, I don't know if I'm following the time or. So IBM today, we and this is important in our region, but it's everywhere. The maturity again. Thinking about data. Today, even data, there is different level of maturities in different companies. And this is how I would say, we define the maturity level of different companies, different of how they use the data and how much they take value out of the data. So today, and this is, you see what's in the middle, this is worldwide. It's not, this is, all the world, we are still in the middle between doing data warehouse and data lake and start really leveraging the data and do self-service analytics and really insightful driven decisions. So the first level is operational. Now this is every customer, everybody, they have this transactional system, ERPs and CRMs, that these are transactional systems. And this is a must because it's the business, it's their core business, right? Then, the next level of leveraging data is building data lake and data warehouses. This is next level. And then, you see, the more you go to the right, the more you can leverage and take advantage of your data. As I said, the third one is where really we start applying machine learning and insight and predictive analytics. And what we have today, a lot of advancement on what we call self-service analytics. We want to offer to the business users the possibility without programming to get some insights, some correlations in the data, some trends in the data. This is what we call self-driven. But also really here, when we start doing this kind of things, then the data, we are getting more value out of the data. And the ultimate goal, and this is when I gave the example of Uber, Airbnb, and this is where the business models, the services we are offering are based on data. They shape their business models based on how data evolves. And this is the ultimate goal, to be able to have the data telling you what service you need to offer, what marketing, when you do a marketing campaign, what people you should target to increase your revenue. In marketing campaign, for example, look, if we send a survey or not survey, an offer for 1 million customers, and $1 per customer, let's say, it's $1 million. But if we know that only 50% of these customers might be interested upfront, if I have something who can tell me, you don't need, if you send to 1 million, you will have only maybe 60% or let's say 40% answer, positive answer, okay? If you can, before doing your marketing campaign, identify this 50% of people that are likely to accept your offer, you send them, it will cost you $500K, and it will have 90% or 70, 80% return. This kind of things where you start really, because you understand your customers, their behavior, their history, and so on. So this is where really, and today, AI will help us. And like executives, they say 83% of them, again, these are worldwide numbers, and we take all regions, including our MEA region. They say that it will be a strategic opportunity for them. However, as you have seen, the maturity level is not there yet. Okay, so they say, okay, AI, it will transform my business. Okay, but they don't have the data ready because their maturity level is still very behind. So this is what we say, there is no AI without IA. No, IA. IA is information architecture. So you need to build this information architecture to access. 80% of people are saying they don't have proper access. They don't know all the data they have. They don't have access to this. Decision makers. And the other, like 81%, they don't understand what data they need. And this is very important. When data scientists today, one of the first challenge is to know if they want to deal with a model, what data they need, and what data they have. So this is why IBM can help, and we're trying to help companies as well, to take this journey and to start really from where they should start, okay? So we call this AI ladder, whatever we can call it, but this is the different steps we think a company should take to get to AI, okay? The first one of them is organizing and collecting the data, First is collecting. Collecting means, as I said at the beginning, is being able to collect data from not just, again, this 80-20 rule. There's 80% of data we call unstructured data. So these are the emails, the videos, the audio. So again, being able to have a system who can capture and ingest all types of data. This is the first step of the ladder, okay? Then being able to, organizing is putting, not just being able to, is classifying the information, is cataloging. We create what we call a data catalog, to recognize business size. Because today when we collect data, and IT, even we speak about big data, is very technical. So how to make this like mashable or understandable by the business? This is why in this level we try to put what we call business glossary. We create a data catalog and we create business meaning to the data. Then when the data scientist wants to create something, he then knows the name of the data, from where to take it. And here also as well, we put the governance rules, because data, again, we have to respect, we have to comply, we have to respect standards, rules, who can access the data, this is very important. Then only then we can start really analyzing. When I say analyzing, is start being able to leverage and take advantage of these data, because like, quality is there and quantity is there. We think, again, you see that trust, it's important. It's one step of the ladder, being able to trust the information, to build an AI and trustable AI system to be adopted or to be accepted by users. And then one of the challenge today companies are facing, it's deploying the models. When we create things, how to deploy them, how to make them available. This is the infuse side, how to integrate it in different things. I choose to put on the right side, this is a bit technical, but today, also, we hear in the market the cloud is another disruption coming in, okay? And some companies will tell that you need to go cloud to use my AI capabilities. Otherwise, you cannot do any AI. This is, you can maybe, what we are trying to, and we are already, we have solutions that bring all the AI capabilities on premises. And we have capabilities to say, okay, we can serve multi-cloud, so we can be able to serve customers. We think that customers is like, even with cloud, they will not go and lock themselves with one vendor. It's like how they acquire software today. They acquire software from different vendors. Why on the cloud they should go and acquire capabilities? Maybe the machine learning or whatever from Google is better than what IBM is offering. So I want to use IBM capabilities, but I want to be able maybe to leverage a capability from somewhere else. We call this multi-cloud. And IBM today, if you have heard, a month back we acquired Red Hat. We paid $34 billion, and basically is to be able to serve this approach of being able to manage applications that has that leverage multi-clouds. Okay, different cloud providers, different capabilities, but also being able to create on premises the same capabilities without being able, and this is one of the problems, we don't want to expose our data on public cloud. We want to be able to build this AI and all these capabilities locally on premises. This is also what IBM, with Red Hat and what we have can bring to our customers. Thank you. Yeah, since 2 months, we launched something called Watson on ICP. ICP is IBM Cloud Private. It's a platform that's based on Kubernetes and Docker, and it is Watson on ICP can deploy capabilities of Watson on premises. To be honest with you, we have a roadmap to deploy all the capabilities you have seen in the previous slide by mid next year. So for now, it's a roadmap. We are bringing these capabilities on premises. It's coming by, let's say, end of 2019, you will have all Watson capabilities on-prem. So yeah, I want to just, as I said, I mentioned this, we created a, look, think about it. Today, a lot of organizations and companies, they are disrupted by cloud. And they say, okay, should we move today? Do we have data centers in the region? Do we have the regulations will allow us, yes or no? And usually in our region, it's still a big no, right? However, the dilemma is, what should I do? Should I wait till the cloud to move or to modernize my applications? So the answer is no. With IBM Cloud Private and IBM Cloud Private for Data, you can start building cloud-native application locally on premises. What does that mean? You will be able to develop applications and microservices application on your premises, like behind your firewall. But these same applications, when you are ready and when you are authorized, or there is data centers on your region or your country, when you can move your data to the cloud, the application will work seamlessly, whether it was the same application. This is what we can actually we can do in application modernization. We estimate today, like, there is a vague of rewriting application. We think all customers across the world will rewrite their applications to be microservices and container-based applications. This is a huge market. It's in multi-trillion dollars. So today, again, can help customers, our customers, to create today these cloud-native application, modernize their application, and be ready to move the workload to cloud at any point of time. Okay? So this is based, as I said, on a cloud, on Kubernetes. It's all open source, by the way. It's really open source, Kubernetes, Docker. And what we do, and on top, let me also mention to you today, when we say AI, data science, it's more a team, I would say, play. It's not a one, I would say, it's not one specialty. So you see here, for example, you have the business analysts, you have data stewards, you have the data scientists, the data engineers, and so on and so forth. All of these people can collaborate together. What we are offering them today is the same platform, same user interface, same experience to do what they have to do in their role. A data engineer, to ingest data, they need ETL capabilities. And to collect the data, they need to have database capabilities, and so on and so forth. So you see, we serve all these types of users with the same platform. And in mind, developing open applications, cloud-native applications. Okay? And you see here, we can help building the data science pipeline from data collection, data organization, till data, I would say, consumption. Okay? So you see, and this is one single platform, easy to deploy. It respects the continuous development and the DevOps rules. It is really one of, I would say, it's the future. You know, it is, you know, our investment in that. It's just, you know, to say it is, for us, it's a game changer in the whole market. And by doing this, we will be able to build, again, we are having AI in mind. So we are building the platform to be able to serve AI. And bringing Watson capabilities on this platform, this is the same. Watson on ICP, this is the same platform, will allow us or allow customers to leverage all the AI capabilities locally. Okay? So to come up, I will go, I think I will go faster a bit. Just, you know, unbiased, I like this example, and you can try it yourself on Google Translation. If you do, you know, we speak trust is important, and bias is there because bias is there because people are biased and training the system with their biased data. This is or the data itself is originally biased without the user knowing this. So one of the examples I like is you go to Google Translation and you translate to Turkish. You take this phrase, he is a nurse, she is a doctor. And you translate to Turkish. In Turkish, there is no feminine and masculine adjectives. So you have a phrase, you just flip it. You flip it and you do Turkish to English, the same phrase. It becomes, she is a nurse and he is a doctor. You know? So it has been trained to say, okay, all doctors are male and all nurses are females. It's just because the data, and is an example, you try it and it's real. And this is the type of things can be big, can be sending somebody to jail and because of his color. So this is why we are doing a lot of advancement, and we have even launched a product. All of this new, and you see it's coming very quickly. We have a solution called AI Open Scale. It has been, again, released this month, or maybe in October. And it has the capabilities to help you open the black box, open the deep learning black box, and try to understand what data has been used, and even tell you your data is biased. And again, it's based on machine learning itself. It uses our technology and this is, again, another game changer. And you see, in adoption of AI, we need this kind of tools. And this tool is a unique thing in the market. You know, it can explain why the outcomes, why the decision was that way, what data has been used. It can track the accuracy and so on and so forth. Okay, and this is a beginning again because it's I would say a new product. It's becoming it will be enhanced over time. Okay, I will see. I think so. Any questions so far? Sorry, Dr. Ibrahim. Maybe not people. No, you want at the end? Sure. Okay. Let me then take 10 more minutes, and then or 15 minutes, and we move to questions. Some of the use cases I will go quickly because, as I said, Dr. Ahmed will go through this, and to answer, again, you see my title there, use cases. It's based on use cases. You have the spectrum of analytics. Okay, AI is on the top, and again, I will not go in details, but from descriptive, and we have got a good explanation: descriptive, diagnostic, prescriptive, and descriptive, whatever. And this is very important because today we can help customers based on use case. We shouldn't push always saying this is AI. It depends. We think data science, and this is where data science comes to the picture, starting from predictive, prescriptive to AI. This is where data scientists will use more these type of capabilities. Okay, so again, we can deliver. Again, I'm not doing marketing here. It's just to say, okay, we know that there is different types of analytics. Advanced analytics is not only AI. So I choose some examples based on, they are worldwide. This is in China about, detecting pollution. And they can today detect pollution in 1 square kilometers. The idea here is in China there is in Beijing there is a lot of pollution. So instead of closing like schools in in all the cities, they can predict 72 hours in advance where they will have high pollution, and they can advise like maybe to close for people they have problems, maybe to not go to this area, and it is very, and it's based on not only, and this is where the combination of technology comes together. It's combined with IoT, combined with sensors, which can send, and sensors today can send a lot of data, sensors and even telcos today, this geolocations things. We are using all of this, and we are collecting the thing today is you have to think is not only your data that are like you can use. You can also think about accessing external data, public, or even buy data from other companies. Today, for example, in Dubai, I know that a lot of banks, they buy data from the telecom companies to locate the people, their geolocation, and they can send them these offers. I don't know if that exists in Beirut or in Lebanon today. For example, if you are crossing Starbucks, you receive immediately a message saying you can have 10% discount if you. And this is what we call streaming analytics. This is the fact that you can react to something in the 10 seconds. So imagine that 30 seconds later, you receive this, and you have 200, 300 meters maybe from Starbucks. You will not come back. So it is very. So this is IoT. Combining also the different data sources is very, very important. The second one is an oil and gas company. It's in Australia. It's called Woodside. This is leveraging, I would say, building a knowledge base that helps them to collect all the expert knowledge. It allows them to save 75% time to search for information that from experts, because and also they have aging people going in retirement, so they wanted to maintain this knowledge, and they have developed a lot of applications. They have developed a knowledge base, a chatbot, because when people they are on sea, they don't have access to everything, so they have mobile applications where they can ask questions and they can have the lesson learned and all of this based on this is. Believe me, when I say chatbot today, when I say chatbot, they say like it's a minimal or it's very narrow application. But chatbots has from IBM perspective, all these capabilities from understanding, reasoning, answering, interacting, and learning. The chatbots today, good chatbots, because some chatbots are frustrating people more than the answer machines or the call centers. But yeah, chatbots is a very, very, I would say, typical application of AI. The third one is on healthcare. So this is for diabetics. It's called Sugar. It's an application called Sugar IQ. And it helps diabetics to predict also their level of sugar in blood. And the accuracy is 85 to 89%. They predict in the 3 next hours. The system, they have a sensor in their body, and they can, with their mobile application, they see that their level of sugar is going up or down 3 hours before. And it's changing their life, right? And the accuracy is 90%, which is really very, very important. This is a chatbot that, finally when we build chatbots, we can, and this is where robotics today, I've seen a video not too long back, a company, they have built a robot that you can train it physically. So the robot, you go, for example, if you want the robots to pick a piece of, in a factory and put it somewhere. So you train it. You just train it by positioning it somewhere and moving the arm and doing the movements that the sequences of movement the robots should do to learn. And it learns from this. So I mean, robotics are a vehicle or IoT systems that can embed a brain or an AI brain. This is a chatbot that has been, it was a chat, normally it's a chatbot in Dubai based on, it helps investors to choose sectors. They can go to a website today. This is called Rashid. You can go to the website. You say, okay, I want to invest in Dubai. What's the best area, or what's the best domain or things I can do? And it can even help you to know what type of paperwork you need. And then they implemented it. It can be a question answer. It's like a search engine, but it can be also built on. This robot, it's more interactive, with voice. So I just...
How do I recharge my Salik?
You can charge your Salik balance by making a payment online or by purchasing a scratch card at certain gas stations. If you would like more information, you can look at my tablet.
How do I apply for a residency visa?
Residency visas are issued by the GDRFA. You can apply for one after receiving a job offer and a UAE entry permit from your employer. You can look at my tablet for details.
So just as I said, it is showing you that you can build your applications on robots, but at the end, you have to build this chatbot itself. Okay, and it's based on voice to text, and as I said, when we do voice to text, then everything becomes easier because it understands Arabic. This one, it supports Arabic. The last example is about, I will not go through it in details, but it is a telco, it's Vodafone in UK, and it's just helping customers to know if they want to travel somewhere, how much it will cost them, the mobile or the phone call, how much per minute, depending on the countries they are visiting. And it's the same chatbot. I will run the beginning of it and then I will stop. But it's same, again, this is one of the ideas I want to share with you as well. AI today, we speak about narrow AI and general AI. All applications today are very specific. You build these chatbots, they know only one single thing. They don't know something. It's just built for one domain. And this is where really we are still far from. We think that in the future we will come to a general AI where we will build a machine that will be really doing everything. But it will be, I don't know, science fiction. Yeah, just, as I said, it's a chatbot. This one, there is no voice, but again, you can have this capability. You can put the voice on top of it. And the next 5 to 10 minutes, I will go through how IBM, how we want to help. Actually, we work with many universities and many customers to help building skills, because we say, as we said, skills today is very scarce, and it's important to build skills. So as we said, skills is not only, everybody wants to do data science, but at the end, we still, even developers, and you see today more and more demand on even developers. So here, just to show you through the life cycle of data we use to build an AI or a data science or machine learning system. You see here, inputting data, analyzing data, and output. And you see that at each phase, how much effort we need from each of the personas. Somebody told me it needs a PhD to explain this slide. But I like, it's one of the slides I like so much, because it explains, the thickness of the line tells you how much, for example, a data engineer is involved in ingesting data. So you see, for example, data ingestion, it needs data engineers, some information from data scientists and business analysts, and also a lot of involvement from application developers. Because sometimes to ingest data, we might need to develop programs. Okay? And so on and so forth. What I want to say here is skills should be built in each of these areas: data engineers, data business analysts, data scientists, developers. So what we want to help actually help business to the business are suffering today from not having these skills. This is a win-win situation. So if we can build the skills, if we can also bring combine or connect the skills or the people having these skills to the organization, that will help as well to accelerate the process. So we can help in training, certifying. We have programs with some universities where we help them to create a curriculum. And not only we help at this side, we can help also delivering some of the curriculum. It can be agnostic IBM. We don't, some of the areas might be generic, but still, we can help organization and mainly university to build curriculums. So one of the things we can do, and I think this is what Dr. Ibrahim will discuss, if we can run kind of a competition, because the idea here is to identify use cases and to combine university with organization, with students, for example, and with different. Even sometimes we open this kind of competition to not only students, to external. I know that, for example, Emirates Airlines, I worked with them. They did a hackathon in Santa Clara, and it seems that companies today, they go to whatever in the US is very popular. They bring their business problem and their data. It was user experience, by the way. They want to see how they can improve their user experience. And they did a public hackathon. And then they have got more than 500 people. And again, I said that ideas is the most expensive part of it. And by doing hackathons and doing this kind of competition, companies and organizations can collect ideas that they have never thought about, and for free, kind of. Okay? So put these people together, putting them in competition mode just to help accelerating the process. We need, and this is where we can collaborate with you and with Dr. Ibrahim and with the school here on organizing it. We need to work. Organization might be government, might be. Some hackathons can be open. It can be multiple organizations working on the same business problem, or going to one organization, taking the hot topics they have. We do for that what we call design thinking, where we can identify and help companies to identify the quick wins, the high value, low risk cases. And then we provide people to help during these events. We provide the tools because we need to use tools, the platform itself, and at the end, also we can provide judges. But it is one of the area. I don't want to say it's not. We are offering only this kind of hackathons. As I said, we can offer programs to help also, educate long-term or on long masters students. And for the people who will participate, this will accelerate their learning. It will show their skills and their maybe talents, and it will help them to connect with organization, right? Today, some of the organizations select people through this kind of exercises. It's a win-win situation for everybody. So, and also what IBM is putting, we put public information or public training on the web for we have one, it's called cognitive classes, big data universities, we have data science fundamentals. All of these are open links or public links, and they give normally badges. I don't know if you have heard about acclaim badges. This is we call open badges. These are badges recognized by many companies, and it's a known type of I would say recognition. And this is the different things we can do together. Hackathons, programs, delivering ourselves things, or even giving access to. What also we can do is give to the university access to our tools so that they can use internally in training or, that people or the students can learn. With that, still have 10 minutes for questions.
Thank you to Dr. Chawki for the introduction. Now we go back to the 2 points you have mentioned, Dr. Haile, about privacy and bias. This one, if I allow me to add one layer to it, is actually what is the perspective and objective and goal. So if you are getting data for the sake of data, does not get you anywhere. So you have the data for a purpose. I want to improve, then I get measure for improvement. I want to benchmark, then I get for benchmark. So 80-20% rule, you know it. There's so much data available, and this is the reason for the bias. Allow me to stop. I'll be talking about it because later on, they are talking about cognitive system as a tool, but they are not including the cognition understanding based on objective and goal and mission. That's a point I would like to highlight. However, I'm happy to take question now for the sake of the 10-15 minute time available. Any question? Okay, you have a big voice.
I'm Diana Buganem. I work at the Ministry of Telecom and Ojero. I'm going to skip the next lecture, but I just want to ask, because I know they will mention it, what are the applications in the telecom sector? Is it the call center or contact center? Is this one of the main applications that AI, artificial intelligence, can be used? I mean, I know it is there, but what else can we have to utilize these new data analytics in telecom sector? Thank you.
So from general aspect perspective, telcos is like any other company. There's 3 objectives, like optimizing or increasing revenue, reducing risk, and reducing cost, right? This is in general. Now what we have seen, some of the companies, you have seen an example of chatbot. This is a common example as well. I have seen telcos monetizing, working on this, like building more big data systems to monetize them. When I gave the example of banking related to buying location, geolocation, the airport, for example, they buy the geolocation for telcos. This is one of the area, because here, as I said, this is also, it's not about big data, it's about streaming analytics. Streaming analytics is the real-time analytics. Is being able, as I said, is sending the message to the right person at the right time. Because also if I'm sending to a man maybe a 10% discount on a woman shop, whatever, maybe it will not work. So we need to capture the information, analyze it, analyze the profile of the person, and then send it. This is also working very well. I think in the IoT side, as I said, there is a lot of, and I don't know exactly what Dr. Ahmed will, but we can share with you the telcos use cases. So again, as I said, there is a generic one, the generic ones for everybody, where it's really optimizing or increasing the revenue, doing marketing campaigns, selecting. As I said, one of the things I know that one telcos is doing is the example I gave. Instead of sending the marketing campaign to, they can predict also churn. They can predict, and I like this one. They can. One of the example of predicting churn, for example, is not. One of the telcos company, they have found that it's not the people who are making the lot of calls who might churn. These are the people who are receiving less calls, because these people are not really attached to their phones. They are high value customers because they use a lot they call a lot, like maybe old people or whatever, but they receive few calls. So for example, this is the inverse. Sometimes we may think that people having, and this is churn is very important.
Is there a question? I can always fit in some question while you are thinking of some. Okay.
Short on delivery. That is the promises that Watson was supposed to do is not delivering.
So it's asking the question that Watson is short on delivering promises. What to say about it?
So this is exactly what I mentioned in companies saying everything if you need is on cloud. If you need to do AI, you go to cloud. One of the problems of Watson was that these capabilities was only available on cloud. And knowing the maturity of people that don't want today, there is few people, even worldwide, not more than 20% of companies they are today on cloud. So this was because it needs all this computing power and all this. It wasn't available on-prem, and this is what delayed it a bit. And as I said, this Watson on ICP that is coming, I'm 100% sure is a game changer. And even with comparing to competition, because we'll have all these capabilities I showed on local. Yeah, this is mainly, I would say, and one of the things, and IBM, we are here, the event is called cognitive. One of the things we have discovered that we were using the cognitive term. We were calling it cognitive computing. And like a year or 2 years back, we have discovered that people are not understanding that it's AI. So they didn't. So now, and you have seen in my slides, I say AI always. I mentioned cognitive, and this is the core. But this was also one of the things we discovered that people are not embracing it because they thought we are not like computing, or sorry, cognitive computing is not really.
Just a comment on this, really. Cognition is different, coming from psychology, is to help in the understanding, and cognitive system, where they are the tool to help in analysis. I personally chose cognition as a starting phase to remove bias. We have to understand the business, see what are the measures, to frame it in analytic term, to get the data to go to the next phase. So cognition is different than cognition systems. System is the underlying tool to understand things. Unless you know where you want to go anywhere. And this is a problem of the bias. I am measuring from perspective of my manager. I'm measuring from perspective of end user. From what perspective? Then you get better accuracy to remove bias. Just the question to the my speaker, for the sake of sharing knowledge, there's a lot of buzzword: machine learning, artificial intelligence, deep learning, clustering, classification. Can you tell me in simple words, I'm a naive person, what's the difference machine learning? What's the difference between deep learning? What's going on? As Dr. Haile said, we use statistics to classify groups, classification trees, decision trees. Now, what do you mean? A neural network, training using genetic algorithms, those, what is the term genetic? Just a new buzzword confusing the hell of us all. Can you explain more about this, since it is an introduction session to basic knowledge and skills?
So yeah, exactly. You know, as you said, machine learning and deep learning is logistic regression. It's a simple things we were always doing in statistics, and now, yeah, as I said, I tried to explain that, you know, when you say AI this is why IBM did this definition of the 4 phases of understanding AI. Underneath, we use machine learning. You know, we use this algorithms, and it depends of what type of problems we are addressing. Some algorithms is working better than others. You know, as you know, deep learning showed that we can solve more complex because we can have more layers and more deep networks. The problem with this deep learning was the computing time. And if we want to inject a lot of data, we were waiting for ages sometimes to get results.
Simple term. Do you agree with me? Yes or no? Yes or no? Because I'm teacher, professor as well. To my understanding, deep learning is a representation using neural networks. Try to map a problem using human brain. This is why I'm calling it deep learning. However, machine learning, I think learning, this is traditional. There's 2 things you have to: interaction, man-machine interaction, and machine-to-machine interaction. When machine-to-machine interaction, those they are calling them deep learning. But interaction between a human to machine, then one to interrogate, ask, then you can use some kind of traditional approach, clustering, classification, where decision trees, regression trees, so the statistics tools that we are all the time talk about it. But I want, just for sake of learning that, tell me I am wrong or right, because this is my understanding of those one for the sake of our colleague.
You are completely right, and you mentioned now just something about decision trees. You know, and you saw this, the deep blue, the Kasparov is no more than a decision tree. It was a very deep decision tree that it evaluates the moves, which moves will be better than others. It's like what we call the enforcement learning. What should I do to get more points? And so, yeah, all these technologies putting together. Neural network, you are absolutely right, Dr. Ibrahim. This is what it's neuron. It's coming from neural. And it tried to emulate. We think this is how the brain works. Of course, we are very far from really exploring all of it, but it's the way we push information from one node to another. Is like how the brains work.
Thinking, not deep thinking. So it's just like the machine came to replace that. And on data, I beg to differ. We don't have enough data. Actually, the biggest problem in the service industry, especially banking, that we don't share data. I mean, every bank has its own data, and every bank has its asset data and liability data. So basically, when you talk about productive data, we don't have a lot of data. So we have to change the mentality. We have a lot of data. We don't have a lot of data. Artificial intelligence has proven success in black and white science, not in behavioral science. Anytime where you have a decision that involves judgmental kind of thinking, artificial science is at the mercy of the data. So the outcome of the process, especially when it comes to prescriptive analytics, you are at the mercy of the data. Bring in garbage, that's what you're going to get at the end. Universities don't share data. I mean, today we have, if you look at all the universities in Lebanon, could you imagine the wealth of data you can have if those universities establish one warehouse of the data? You have what? 50,000, 100,000 students. These are individuals to be served.
This is where I spoke about data monetization, and a lot of people start realizing it, even private companies. Government state, of course, demographic data, maybe not sharing personal information. But for example, Google today, they have this is how they make money. This is demographic.
And one correction, GDPR is about sharing data. You're not supposed to share that. It's like the bank has data about me, it's not supposed to share it with an outsourced provider.
Well, this is a challenge we really need to be aware of. If you want to have value, you have data, you have to value it. This is really the question. We don't share, and we will not leverage it if you don't share it. This is a challenge, and at least, however, within an organization, you don't need to share it. Use it inside. That's why I'm having challenges where you use the data inside. So let's not share it. Let's use the data if we have it. So let's start building blocks. Show the value of the data you can get out of it. And then people will follow. So we need to set a role model for success. And I will show you, we have in e-government, we have done cognition and ethic management. In 3 countries, we succeeded in 1, we failed in 3. Simply because people do not share data or you don't get the management support. So think a little bit, I'm adding cognitive analytic management. Understand what you want, write analysis to take you where you want. And if you don't have the backup of management to help to you and your analytics, sorry. This is what we need to have challenges, identify them, and work on them. It's a long story, but it's better than gut feeling. Start somewhere, maybe the decision might not be right, work around. Rather than being in that corner, you might start from here, and then in this region. So it will help. It will augment our thinking, and let's leverage it if we were to benefit. And the world is moving that direction. Do you want to be a player or not? Yes, go ahead. Approve. Correct. Well, there's only 1 minute for any question. We can share it over coffee break, and then we'll have a whole day to discuss. If a person has a question, we'll have a next time to ask it. If you don't mind me, with permission, Dr. Ahmed will be with us after the break over lunch. We can do it. No one will be left without a question. Thank you very much. Thank you, Doctor. Well done.